गुड इवनिंग एवरीबॉडी, माई सेल्फ आचार्य विश्वेंद्र। आज कुछ केसेस आपसे डिस्कस करूंगा। मोशन ऑफ चार्ज पार्टिकल अंडर द इन्फ्लुएंस ऑफ मैग्नेटिक फील्ड। तो आइए स्टार्ट करते हैं। बड़ा जनरल सा टॉपिक है। जब किसी चार्ज पार्टिकल को आप एक मैग्नेटिक फील्ड में प्रोजेक्ट करते हैं, सो डिपेंडिंग ऑन द एंगल बिटवीन मैग्नेटिक फील्ड एंड द वेलोसिटी, various trajectories are possible. So we shall discuss some of the possible cases over here. So let's begin. The very first question is, when magnetic field is parallel to velocity, so we know that force is equals to magnetic force on a charged particle qd cross b, and this is your qvb sin theta into n cap. So यहाँ पर अगर v वेलोसिटी वेक्टर और मैग्नेटिक फील्ड अगर पैरेलल है तो यहाँ से थीटा आपका जीरो आ जाएगा, और अगर थीटा जीरो है तो मैग्नेटिक फोर्स भी जीरो होगा, और अगर फोर्स जीरो है तो एक्सेलरेशन जीरो होगा, और एक्सेलरेशन अगर जीरो है तो वेलोसिटी कांस्टेंट होगा, और वेलोसिटी अगर कांस्टेंट होगा तो पार्टिकल विल मूव इन अ स्ट्रेट लाइन। सो एज स्ट्रेट फॉरवर्ड एज that when angle between velocity and magnetic field is zero, locus will be a straight line. Particle will move with a uniform velocity and speed, obviously. Next question, velocity is anti-parallel to magnetic field. So here angle is 180 degree. So in that case also cross product will be zero. So force will be zero, and hence acceleration will be zero, and hence velocity will be constant. And velocity is constant, that means speed will also be constant. So that locus will also be a straight line in both the cases. That is a very interesting case then when magnetic field is perpendicular to the velocity. So in this case, what will happen if we assume that charge is positive? So if we calculate V cross B, so circulation of V cross B will be anti-clockwise. So that will be up the plane. Up the plane means along z-axis. And Q here is positive. That means force will also be along plus z-axis. So force will be along plus z-axis. Velocity will be like this, and magnetic field will be like this. Now this force is perpendicular to the velocity at every instant. And if force is perpendicular to the velocity at every instant, we know that locus will be a circular motion, uniform circular motion, and its plane will be the plane of velocity and acceleration. So force is over here, velocity is over here, so its center will be toward plus z-axis at some point, and it will move in a circle like this. So locus will be circle in the xz plane. So if we see the projections, it will be like this. This is your x-axis, this is your z-axis. So it will move in a circular way, and if we observe from over here, the direction will be clockwise. So it will just move like this with a uniform speed. And one more thing is, here center will not be exactly at the origin, so it will be at some point. Let us say this point has the coordinate 0 0 r. So here this point will be 0 0 r. It will not be exact intersection point of x and z axis. So there will be locus will be like this, centered around here. So we can say that it will be like this. And this is certainly z-axis, but let us say this is an axis parallel to the x-axis. If I draw it like this, this axis I name as x-axis. So that will be the locus of the particle. So it will be a circle in xz plane. That's a very interesting question here. Now, if charge is negative, so what will happen is, if Q is negative, then everything else is in the same direction. V cross B will be up the plane. But due to charge is negative, force now will be directed towards minus z-axis. So situation will be like this. Right here it is x-axis, here it is y-axis, here it is z-axis. So force will now be directed like this. So it will be having its center just like 0 0 minus 1, and velocity is over here. So it will move like this, and certainly the center is here, so it will move like this. So here thing is that it will move toward minus z axis rather than plus z axis. So if we draw, let us say this is your minus z axis and this is your x axis. So let us say this has x dash axis. So same concept will be here, but here it will rotate in anti-clockwise sense. As you can feel over here, if I look through the y-axis, then this axial plane will be, the particle will be moving in anti-clockwise way. So it will move like this with the speed v. So that will again be circle in axial plane, but here sense of rotation will be anti-clockwise. So that will be the locus of the particle. Then next question comes, if magnetic field is downward, charge is positive. So again, we can see that here circulation of V cross B will be clockwise down the plane. So this simple case will be applicable over here. In the next case, Q is negative. So if Q is negative, so that will correspond to this case. Because V cross B is clockwise, so it will be down the plane, but due to negative charge, force will be up the plane. So force will be up the plane, so structure will be like this, and structure will be like this, and the locus will be like this. So this is how you can visualize things. Now move on to the next part. Velocity is making an angle with the magnetic field. So what we can do is that we can break velocity as v cos theta and v sin theta, and we can apply superposition principle. So we can say that there are two particles. First is moving along magnetic field, and second is perpendicular to the magnetic field. Charge is positive. So due to this velocity, it will move in a straight line along the field, and due to this velocity, it will move perpendicular to the field. So its locus will be a helix, and here we can see that it will be, if I say this is your v sin theta and this is your magnetic field. So v cross b here will be clockwise, so it will be down the plane. So force will be like this, and if force will be like this, then particle will move in a, in this plane. You can say that x, this is x axis, this is your y axis, and this is your z axis. So particle will move in yz plane due to velocity component v sin theta, and it will move in clockwise way. So the entire locus will be the superposition of a particle moving along yz axis in a clockwise manner. So it will be like this with a straight line motion, which is given by the component v cos theta. So ultimately it will move like this in a spiral way. Sorry, it's a helical way. It's in a helical way. And thing here is that the sense of rotation will be clockwise, so it will move like this. So I'm observing things from the front. So if observed from the front, it will move in a clockwise way, and followed by the the straight line motion due to the component t cos theta. So it will be the thing. Now in this case, if v is negative, so we can say the direction of force will reverse. So direction of force will reverse, so it will move in anti-clockwise way. So locus will be same, except the fact that it will move in anti-clockwise way. So it will move like this when I observe from the front. So it will move in anti-clockwise way like this. So that will be the motion of the particle. Now in this very simple question, if charge is 0, force will be 0, so acceleration will be 0, so velocity will be constant. Hence we can say that particle will move in a straight line. So that's a very simple question. Next is if we have both electric as well as magnetic fields. So we can say that initially velocity is along magnetic field. So force due to magnetic field will be 0. Hence it will accelerate it due to the electric field. But since velocity will be along the electric field, which is along the magnetic field, so force on the charge due to magnetic field will be 0, because its velocity at any instant will certainly vary in magnitude, but its direction will always be along the magnetic field. So magnetic force will be 0. Hence it will move under the influence of electric field, and hence the motion will be in a straight line. Now there is another interesting case. Then velocity, electric field, and magnetic field are given over there for a positive charge. So locus is same as that of you can say this case, but here the difference will be that this electric field will certainly increase the velocity, magnitude of velocity. So it will be an helix, but with increasing pitch, which is the horizontal distance traveled by the particle in one complete, when it moves through 180 degree in the, you can say that angular motion, when the angular motion completes one rotation, so that horizontal distance that it travels is called the pitch. And if electric field is over there, so it will accelerate along the pitch, along the the axis of the helix, and hence it will be an helix with increasing pitch. And assume that the Q is positive, so that means that there is one interesting case if electric field, magnetic field, and velocity all are perpendicular to each other. So let us see what happens. So if charge is positive, then we have electric force along z axis, and we have V cross B. So this is clockwise down the plane. So this will be the magnetic force. So we can say that electric and magnetic force are opposite to each other in both the cases. So there are two cases: if electric force is equal to magnetic force in magnitude, and second is it's not equal. They are not equal. So if they are equal in magnitude, that means net force will be zero. Net force will be zero, so motion will be a straight line, and it is called undeviated movement. And if electric force is not equal to magnetic force, then certainly there will be a force. And if there is a force, then obviously particle will undergo deflection. And this is a special case in which electric force is equal to magnetic force. So electric force has a magnitude Q. Magnetic force has a magnitude QEB, because here angle is 90, so that will be QEB. So if V is equals to E by B, then a particle will move in a straight line, undeviated motion. And this is the simple concept behind undeviated charge particle motion. That when a charge particle moves through closed fields such that V is equals to E by B, then there is no net force on this. And this concept is used in velocity selector, where you select particles with specific velocities. If you want certain particles, let's say you want alpha particles with speed having 2 raised to 10 raised to power 6 meter per second. So you just apply electric and magnetic field such that ratio of electric and magnetic field is 10 raised to power 6. So at this exact ratio, there will be no force to the charged particles, and those particles will go straight away. You put a container over there and you can collect all the particles at that location. So this is how we can exploit the use of understanding of the forces on a charged particle, especially forces in a combined electric and magnetic fields. So it has got very many technical applications. Out of it, the first is choosing a velocity selector, or choosing charged particles with specific velocities, which may be used in nuclear reactions to create new elements, to generate new elements, or to search for more fundamental particles, more subatomic particles. So it's all about technical exploitation of that. So we discussed today about the forces on a charged particle in an electric field, in magnetic field, in combined fields. We discussed number of questions based on that, and these concepts have been asked many times in JEE Main, JEE Advanced also, in NEET also. So that is very important concept. If you have any doubt, you can ask in the comment section. Thank you very much.